In 1958, one scientist received the highest honor in science, a Nobel Prize. His discoveries helped create modern genetics. His name appeared in textbooks around the world, but there was a problem. Some of the most important discoveries behind that success came from another scientist. A scientist whose name most people have never heard. A woman who spent years making breakthroughs that changed biology forever. Her name was Esther Lederberg, and for decades, history almost forgot her. Esther Lederberg wasn't born into privilege. She grew up during the Great Depression in New York. Money was scarce. Opportunities were even scarcer, especially for women. When she entered college, even supportive teachers warned her that science would be a difficult career because she was female. Most people would have taken the hint. Esther didn't. She studied genetics at a time when the field itself was still young. She worked long hours, survived on almost nothing, and pursued research with relentless determination. What she couldn't know was that her work would help unlock some of biology's deepest mysteries. In 1950, while working in a laboratory at the University of Wisconsin, Esther noticed something unusual. Inside ordinary bacteria was a hidden virus. Today, it's known as the Lambda Phage. At first glance, it didn't seem remarkable, but Esther discovered something revolutionary. This virus could hide inside bacteria for generations without destroying them. It could become part of the organism itself. That insight helped scientists understand how genes could be switched on, switched off, transferred, and inherited. Modern molecular genetics would eventually be built on ideas connected to discoveries like this. Yet, the Lambda Phage was only the beginning. Soon, Esther would create a tool that changed biology forever. For years, scientists argued about a fundamental question. Do organisms change because their environment forces them to? Or do random mutations already exist before the challenge appears? Esther helped answer that question. Using a simple piece of velvet cloth, she developed a technique called replica plating. The method allowed scientists to copy bacterial colonies onto multiple plates while keeping their exact positions. It sounds simple, but the results were profound. The experiment showed that antibiotic-resistant bacteria already existed before they encountered antibiotics. The mutations came first. The environment merely revealed them. A debate that had lasted years was finally settled. Today, the technique is taught as one of the foundational methods in microbiology. Millions of students have learned its lessons. Most have never heard Esther's name. As Esther's discoveries transformed science, recognition went elsewhere. Her husband, Joshua Lederberg, became one of the most celebrated geneticists in the world. In 1958, he received the Nobel Prize. Esther did not. She struggled to secure permanent academic positions. She was often viewed as an assistant rather than an independent scientist. Many textbooks highlighted discoveries without properly crediting her role. This phenomenon became known as the Matilda effect, when the achievements of women are attributed to others. Colleagues who worked with Esther described her as brilliant. One even called her a genius in the laboratory. Yet genius alone wasn't enough to overcome the barriers of her time. Esther Lederberg died in 2006, but her discoveries never left. They continue to shape genetics, medicine, biotechnology, and our understanding of life itself. Most people will never know her name. Yet every day, scientists build upon foundations she helped create. And perhaps that's the strange thing about progress. Sometimes the people who move humanity forward aren't the ones history remembers. They're the ones who made the future possible.